SwayamPrabha. Digital India. Educated India.
So, we have understood plastics, that they are of basically two types, thermoplasts and thermosets, and yes, we had seen the special applications where it is creating an expression which is the architect's imagination application, and obviously it is also having some purpose or some function. And now we will be entering into the different types of plastics which we need to know, because we have seen a number of materials, but which is what we need to know or get aware as architects, and also need to know what is the purpose, why it is being used. Now, we will enter into the different types of plastics, not the types based on thermosets and thermoplasts, but further down within the thermosets, within the thermoplasts, within the elastomers, which is the rubber part, which we did not cover in the previous lecture. We will just mention those considering its application in building industry. So, we will try to cover the polyvinyl chlorides, which is the third most used plastic in the third most used plastic material in this industry. We have acrylics, we have fluoropolymers, the polycarbonates, polystyrene and polyethylenes. So, we will try to find the particular or specific properties what makes it usable for the particular purpose. So, first let us try to see this slide. Here you see the same names, the thermoplasts, the thermosets, and also there is another in orange what you see here, which has low modulus of elasticity, which is nothing but the elastomers, which is also derived from petroleum. We have rubber, neoprene, EPDM and butyl rubber. Coming to thermoplasts, these are more what we use. The polythenes, the polypropylenes, the polybutanyls, acrylic, vinyls, polyamides, polycarbonates, fluoropolymers. Now, here in the polyethylene you see high density polythene and low density polythene, and we also have another intermediate medium density polyethylene. Similarly, with the vinyls you see you have polyvinyl chloride, chlorinated polyvinyl chloride and unplasticide polyvinyl chloride. Also on the fluoropolymer side you have polytetrafluoroethylene and ethylene tetrafluoroethylene, PTFE and ETFE. So, you will come across the terms PVC, PTFE, ETFE, LDPE, HDPE, acrylic, which is actually PMMA, but it is more known as acrylic, means more available name is, more used name is acrylic, and other is polycarbonate sheet, which has replaced GI sheets. Any kind of corrugated metal sheets. Other is the thermosets. You see the resins, polyester resins, phenolic resins, epoxy resins, and the formaldehydes, melamine formaldehyde, urea formaldehyde. Where do we see? These are all in adhesives. EPDM, where did we hear this term? When we were doing damp proofing. So, these are the, if you remember this slide, these are the major types of plastics used in our domain. So, you see sheet form, you see molded form, you see molded forms of chair. This is again repetition of the pictures. So, we will enter into the major component, what has plastic replaced and who has replaced. Plastics have replaced glass in sheet form. The acrylic, it has replaced glass. Plastics have replaced galvanized iron sheet, again corrugated acrylic sheet or polycarbonate sheet. Replaced metals in pipes for sanitation, water supply, etc. Reinforced plastic replaced metals when used in pultruded form in door window frames. Replaced wood in door window shutters, replaced wood in indoor applications like furniture, replaced wood in electrical wiring application with plastic casings. Wood fiber materials, plastics have replaced for acoustical boards. 10% of sand can be replaced with plastics in a concrete mix. Polymer modified bitumen, that is ModBit, we had discussed during bitumen, is application of plastics, giving it different property. So, plastic which was not degradable, not degrading, can go into road constructions, modify in its modified form, in its own form, modifying bitumen. So, plastic is versatile. Now, we first discuss polyvinyl chloride. You had seen a number of pictures, and as I told you, the carbon chlorine bond of PVC is hydrophobic. So, it resists oxidation, it is anti-corrosive and does not burn. It is non-flammable, unaffected by chemicals. Hence, it becomes a carrier of chemicals. It becomes a carrier of corrosive items, the shear lines. The shear lines, if it is metallic, it has acidic environment inside it and it gradually gets eaten away by the, gets corroded away by the soil it carries, which is not possible if it is PVC. So, PVC is replacing metals, particularly in these building service lines. Now, PVC is very hard and rigid when it is considered alone or when it is considered as the binder, but it is the phytalates which acts as the plasticizer and keeps PVC very soft like rubber and helps it in getting in sheet form, which can be further rolled into pipe form, can be molded into any profile. Now, PVC, because it is not affected by chemicals, it finds maximum application in hospitals, chemical and pathological laboratories, computer laboratories. It is hydrophobic, it takes out the dust and the water along from it. It does not allow it to stick. It does not allow organisms